Hi, this is our last lesson on 2D and 3D shapes. This last lesson, 12-5, is about 2D slices of right rectangular prism, or pyramids. 12-4 was about slices of right rectangular prisms, and 12-5 today is about slices of right rectangular pyramids. So we see the shape come up to a point because we are looking at a pyramid. It gets its name rectangular because its base is in the shape of a rectangle. Okay, if you make any horizontal slice or a vertical slice through the vertex of a rectangular pyramid, the resulting cross section is a rectangle or a triangle. We can do a horizontal slice.
Note that these rectangles all have the same shape, but are different sizes.
Where we're slicing across it. The size of the rectangle depends on how far it is from the base of the rectangle. So all of these are smaller than the bottom base, and they get smaller as they go toward the vertex at the top here.
Note that these triangles have the same height, but different lengths of bases.
These are vertical slices, so we're cutting down on the figure, and we're going through the vertex. So we're cutting right on the top point, going down either this way or cutting down the other way, the blue way. Both of these cross sections that we receive are isosceles triangles. So we know that this is the same length as this, and in this triangle, this length is the same as that length. The base of the triangle is equal in length to an edge of the rectangular base. The height of the triangle is equal to the height of the pyramid. So on this blue triangle, the length of its base for the blue triangle is the same as the width here of this rectangle on the bottom. It's just as tall as the pyramid. Looking at the purple triangle, the length of its base is the same as the length of this rectangular bottom, and the height of the purple triangle is again the same height as the whole pyramid. Okay, here's our first example. As we need to rearrange the tiles to match the cross section with the rectangular pyramid and the plane slicing it. I would suggest you pause the video at this point and try to match them up on your own, and then you can play the video to make sure you did it right. Well, we have to be aware of each of these go. Whenever we cross a pyramid horizontally, we get this rectangle shape. So it'll be this one. It's hard to tell just from the 3D picture the size of our rectangle, but we know it would be smaller than the size of this bottom base rectangle. So the base is 3 by 6. So our rectangle, whenever we cut it up here higher, would be smaller than that. In this case, though, they tell us it's 2 inches and 1 inch. Okay, so we have two triangles here that would go with the vertical cut. For this triangle, whenever you slice down, the length of the base of your triangle should be the same as this measurement of the base of our pyramid. So the first, or the 3 inches, would go with this one. And in this triangle, which is harder to see because it's so slanty, the base of this triangle, it's like this green part, matches with the base of the pyramid, this length going this way, the 6 inches. So make sure you have them all matched up correctly. Okay, what are the shape and dimensions of the cross section formed by slicing the pyramid as shown? Well, we can color or highlight the pyramid that we're, or the triangle, I'm sorry, that we're slicing. We can even sketch it here to the side so it looks something like this. We want to know how wide it is, and we want to know how tall it is. Well, the height of this green triangle is going to be the same as the height of our entire pyramid. So 6 inches for the height. And the base of this green triangle is the same in length as this measurement, 4 inches for the base of our triangle. This part. Explain how to slice a rectangular pyramid to get an isosceles trapezoid cross section. We've looked at how when you cut horizontally, you get a rectangle. When we cut vertically down on it, we saw that we got triangles. Can you think of how we could cut this shape so that we would actually get a trapezoid? Well, we have to cut it at an angle. Not vertical, not horizontal, but at more of an angle. Here's the example. If you cut kind of at an angle, like down this way on the shape, you will get a trapezoid. So this side would be parallel to this side, and it would be isosceles, an isosceles trapezoid, because the measurement of this side and this side would be congruent or equal. Okay, draw and describe a cross-section formed by a plane that slices a rectangular pyramid as follows. Okay, so you want to start by drawing your rectangular pyramid. So you do start with that rectangle base. And then it helps for me to think of the vertex here at the top and then just connect down so that you can sketch your own. But mine here are already sketched for me. So I would just draw a cross-section formed by a plane that slices the rectangular pyramid. Okay, this one is a vertical and it intersects the front face and the vertex. So we would cut down on it. We know that vertical cuts of rectangular pyramids like this are going to create a triangle cross-section. We want to cut the front face, so this face that's toward us. Then you would see that cut being made on the other side and across here. We want to cut this one horizontally and halfway up the pyramid. We know when we cut a rectangular pyramid horizontally, we get a rectangle shape. So we cut it halfway. Here's maybe a better visual for you to see. So this would create an isosceles triangle. This measurement of our triangle and this measurement would be congruent or equal. The width of the base of this triangle would be same as the width of the base of this rectangle. And the height of our triangle, the purple, is just as tall as the pyramid. This one we're doing a horizontal cross sections. So we do get a rectangle. This rectangle is smaller in size compared to the base rectangle. Draw and describe two triangular cross sections, each formed by a plane that intersect the vertex and is perpendicular to the base. So you're going to cut through the vertex and be perpendicular to the base, making two different triangular cross sections. So whenever we get a triangular cross section, that's because we're cutting down on it. If we cut horizontal on it, we get that rectangle cross section. So we're cutting down on it. We could cut this way. We could even cut down on it through that top vertex and cut through it this way. Oops. This way as well. Oh, that is so sloppy. There you go, you can see it better. Here's much better pictures. Both of these triangles are isosceles. That's important to note. Both of them are just as tall as the pyramid. Whenever we cut this way, the base of the triangle matches the length of this rectangle. And whenever we cut this way, the base of our triangle matches the width of our rectangle. Explain how to slice a rectangular pyramid through the vertex to get triangles of many different heights. Well, whenever we cut straight down, right down the middle, we get a triangle that is just as tall as the pyramid. Can you think of a way to cut down still through the vertex, but we would get maybe a taller triangle? If you cut down at an angle, you'll get a taller triangle. So whenever you cut straight down, where this would be meeting the bottom at a perpendicular angle or right angle, this right here would be a right angle, you get a triangle that's just as tall as the pyramid. But if you were to cut right down through the top but kind of slant it, not straight down, you'll get a triangle that is taller. Alright, that's it for this lesson. Go ahead and begin on the practice for 12-5.